Now it's time for the experts' address from the industry and the government. With this, I invite Mr. Vipin Tyagi, former Executive Director C. to address the 18th Infotech Forum with his new avatar as the technology evangelist.
Good morning, good time, wherever you are at this point in time. I have been associated with R India for a very long time, mostly, in different avatars. And these avatars were, a CEO or the, manager, visionary in technology. That's what I've been talking about. Most of you would have heard me there if you attended previous one. This time, I have been lucky to get a little bit of the time to really think and concretize. Okay, the new technology area. So consequently, I decided that let me share with all of you some exciting things. And the format here is next 20 minutes. What we are going to do is answer these 5 basic questions. I have put emojis on the side and somewhere in between just to remind you that this is not a learning exercise. This is a thinking exercise. And also, this is all about what is going to happen. So, we could be, having multiple alternates and all of that. So, what are the questions that I'm posing to all of you? And I will attempt to keep it as light as possible. Uh, what is the present state of cloud computing? All of us know. Also, so I'll touch upon that. Then I'll talk about the issues and challenges in the present architecture of the that we have cloud-based, multi-cloud-based architecture. Then I'll have the motivation for think beyond the status quo. Why should we think beyond what is as of now? And then, are there any theoretical limits to the architecture? Okay, this is not going to be. So I'm not going to talk about the equations here. Uh, but I'm going to talk about the concepts. What is my proposition for new architectural evolution in next 5 to 6 years? Finally, if the time get overshot, we are all going to blame it on Deepak Sahu. Okay, let's resolve because he gave 15 minutes. I made it 20 minutes. Now you can't do research of so many years in 20 minutes. So we'll all blame it on him. Okay, all right. So we don't know traditional model where rigid, siloed management, where labor intensive, everything has to be put together. The compute and the storage were more in focus. And what happened is that then we moved to cloud because of virtualization, where the service anytime, anywhere. There are no problems with the network PAN protocol and protocol when protocol. All of those were included, and then load sharing was possible, sharing of resources was possible, large scale hardware, software could be put wherever you want these to be there, and consequently, the we had a big data coming in. We still had the siloed management, and but what happened is that we had difficulty in admission control. Who's coming, who's going? So there were security issues which were there, right? So consequently, what happened is that we came to a situation where uh, we had a multi-cloud architecture which came about, and then now what I'm proposing is that we go for cognitive self-aware application, which are multi-cloud management is integral part of the basic functions, building block, the security and privacy and transparency are the basic building block, distributed software on simple generic hardware at the edges. So that's what is what I'm proposing, and I'll all try to do. Why we are doing is that cost, availability, scalability, manageability, energy consumption, the load fluctuation that happens, we see all the time. The load is fluctuating, right? Complexity of the managing the whole thing, latency, how quickly I get response, and quality of service being the main motivation. And so consequently, what we are talking here is that now let's see, 5G is coming. Everybody talks about 5G, but I have never heard anybody talking about what will happen with the 5G onto the IT architecture. Okay, so interesting thoughts. Okay, look at emoji. So, interesting thoughts usually create the problem subsequently. So you have denser and megabits per second per square meter. So in a cubic meter, sorry. And then you have the response, which will be in 1 millisecond, quicker, bigger, because 20 gigabit is the data consumption speed, and user experience should be of the order of 100 Mbps. Okay, megabits per second. More dynamism, 500 kilometers. The car is going, and you are still having the same experience of at least 100 Mbps. And then if you're static, you are having experience of 20 gigabits. More density, slicing of the network. So you slice the network and have more density, for the applications. Greener, 100 times less power consumption. These are the 5G goals which have been set out. Okay, so let us look at what goals can be met with the current architecture. Okay, so cloud architecture, can it handle denser? Denser means I gave you the number. Answer is no. If it is so dense, it's coming from somewhere all aggregated. 10 million devices in a square kilometer, and all giving you all kind of megabits. There's a difficulty as of now in my assessment. Response in 1 millisecond, absolutely no, because transmission itself takes so much time, because your data center is somewhere, your user is somewhere else, so you can't meet that. Bigger, maybe, because 20 gigabit per second consumption, because YouTubes and all of those VR applications which are being targeted are currently running. So possibility by upgrade, and let us see what happens. More dynamism, cannot be addressed, because latency and the response time, all of that creates big problems. So you need to have the architecture evolution which is going on as of now. More diversity, maybe, by having different slicing. Greener, absolutely no, with the current kind of practices that we have. Also, let us look at the, let me go back. Okay, today's cloud architecture is based on distributed databases. Distributed databases are, I'll show you what people are talking about, these distributed databases. There are three things which are very important. One is consistency. Everywhere it has to be the same. Partition. I should be able to make more and more partition on the storage, and then it should be available, 100% availability. And there is a cap theorem. I don't know, called also viewer theorem. They say that you can have guarantee of only two out of these three: consistency, availability, and partition tolerance. And that's what has been talked about. Most of the CIOs, they say that it is difficult to overcome in microservices environment. The data storage is becoming very tough for them. Finding that database is becoming tough for them. They say that our modern applications need to choose the microservices architecture, but actually in the storage which exists as of now. Okay, so there need to be strategies, because in this my model that I call it runs model, and runs model is that you have to have the availability, reliability. Okay, run, then user friendliness and novel innovation, scalability has to be assured, right? And that is not possible with it. Then engineers are there to solve these problems, and I am an engineer with a computer science background, also business person, so I need to make money. ROI is what I care for all the time. So today's another thinking, by Mr. Gödel, with Gödel's theorem, he says that you can't have the consistent formal system which is managed enough, which can manage itself, and the management is incomplete. So you can't have the manageability from outside. So it means that you can't manage things, uh, by layer and layer of management. Managers, manager. All that is going to be tough unless you have the built-in. Okay. Let me be again simplistic here. We all know network. What is this cloud architecture consists of? Now, okay, consists of network devices and appliances. We all know all these routers, with switches, and all of that, right? Then network overlay protocols. You have DNS protocol, DHCP protocol, SGTP protocol, SNMP protocol, FTP protocol. All of these, like TCP, UDP. You have the ARP, RARP, and MAC layer. All of these are network overlay protocols which are there on top of a physical layer like Ethernet, token ring, and stuff like that. So you have all that 7 layers. You remember all those 7 layers is what the protocols which are there. Barring the physical layer, we talk about most of it is in software. And then you have the virtual machine overlay. And the moment you bring about the virtual machines, you have the orchestration issues. I don't know what is running where. I don't know really, right? Load balancing. The load is coming from which VM to which VM and all of that. Discovery, monitoring, and container networking. Now, this containerization actually creates some opportunities for providing better service. At the same time, some degree of complexity. Okay. Now let us come back, and then let me go back one slide. So you see on the right hand side the picture that says COT server, and then network overlays, and then you have all the applications which will come about, right? So what is happening in reality? Wake up call, okay? Some people may be sleeping, but it means that industry today, what it is facing is that we have the layers of rigid infrastructure, conventional computing. Then on top of it, our cloud computing, and then we had multi-cloud, all of that, and then administration, automation of administration, and point of diminishing return is what it is reaching. Because what is happening is that there's a complexity cliff. Scaling the number of compute element means more servers is not resulting into the same efficiency, resiliency. So things are breaking up, and then you have the all kind of data centers, complexity on top of it. And the most important out of those now is becoming service anytime, anywhere, hyper fluctuation. The load is shifting, and our response time is not fast enough. Then you have big data, which determines a lot of things. So these are all creating complexity, and consequently, you have the issues with your storage. You have issues with your multi-cloud resource configuration. You have to configure everything dynamically. So there are so many elements to be configured. It's a problematic stuff, right? The evolution, so what happened? This evolution also generated some of the things I already talked about. The practice of adding more hardware and more VMs actually reduce efficiency incrementally. Okay. The return start diminishing due to overheads and complexity. Response time events like sudden increase in demand creates a problem. A spike in demand is not matched by the resource reconfiguration speeds and automated fashion. There are theoretical limits to storage by Cap theorem. Okay, computation limitations arising from Turing machine architecture. Now, this is a little bit more profound, so I'll give it a go. Computer science guys understand that Turing machine itself has its own limitation in handling the sudden demand which will come and different variant of load. Inadequacy in monitoring and control. So you have the, remember this, fault, configuration, accounting, performance, and security is all called FCAPs. Now, FCAPs are traditionally, they require all management. They are backbone of the consistent systems with reliable systems, like runs model that I talked about. That is only possible if you can take care of FCAPs. So what is happening is, rather than having the infrastructure-centric approach, we need to go for the approach which is workload-centric. Okay, so workload-centric means data integrity, availability, security, performance, scalability, capacity. Also the runtime. Oh my God. Okay. So it is running. See the user complexity which is increasing. Workload, availability, scalability has to be going up, and then cost complexity has to come down. This what there is a guy called George Gilder. He has written book Life After Google, and that's what he says, that we are reaching now a situation because security actually is not a overlay, as they say. Okay, it's actually built into the whole thing, and that's why scale, resiliency, and efficiency are the core of the what need to be managed, and SLA need to be managed. All of that need to happen. So these are all problems because of which the architecture has to undergo change. And then somebody has given a good quote, Michael Waldorf. He says that the chaos is constantly shifting the battle zone between the stagnation and anarchy. So you choose stagnation, or by change you bring about the anarchy, the one place where the complex systems can be spontaneous, adaptive, and alive. So what need to be spontaneous, adaptive, and alive? Very easy said than done. Thanks to the lockdown, thanks to Deepak for prompting me to do this for all of you guys. The talk is over. Let's all enjoy. Okay.
Thank you, Mr. Tyagi. I feel we should get ready and think about life after Google. The key takeaway is there is no end to technology, and the customer should be empowered with limitless solutions.